Hold on. I'll think of the name. There's a shusher in there. Like the main leader has like a shusher, a stick. Anyways. When sketching the graph of a quadratic function within a context, right? If there's a context, there's a word problem attached to it. You must label, right? You have to label the axes with words and units. So you can no longer get away with x and y. You have to go, what does x represent? Is it time? Okay. What units are we talking about? Is it days, years, months, seconds, right? You got to put that in as well. So make sure you do both of those. The question will tell you that, so you don't even have to guess. Just like before, we find, I would say, vertex and intercept are key. Okay? Use your calculator for that. This will give you a good idea of what scale you will have to use when you have to graph it. And I want you to not be scared of graphing by the end of this class. So not this class, but the course in general. Don't be scared of graphing. Most of the time, I will say most of the time, the variables will be positive. So the majority of our graphs will be happening in quadrant 1. Let me see if I can focus this here. There you go. So if you're in physics, some of this is going to kind of be like, oh yeah, I've seen quadratics in physics, right? So projectile motion. So for example here, h of t is equal to negative 4.9 t squared plus 17t plus 2. And here's where it starts changing, right? Where h of t represents the height in feet, and t is the time in seconds. Now, I want you to know that this is y every single time, okay? That's your y variable. And this is x every single time. It goes on the x-axis. No exceptions. We'll never trick you there, okay? Which means that h of t goes here, so we'll label it height in feet, okay, height and feet, and t here, which is my x variable, represents time in seconds. Okay. So that's the first thing I want you to realize. This is what to expect. Okay. Now these points all represent something very unique. Okay. Let me just get my notes in order so I don't forget to mention. So this used to be the y-intercept. We used to just refer to it as the y-intercept. But in our case, it's also the initial height. Sorry. We will be given the initial height. This will tell us like how high was this ball, perhaps, or whatever was thrown up at the very beginning. So when time is 0, what is the height? Okay. So this would be 0, a number. Okay. So remember, every single point. Let's do this right here. Every single point is now time and the height at that time. So every single point is telling you both pieces of information, like the time and the height. So this is why this is initial height. So your time is 0, and you will be at a certain height in this case. Okay. This is the vertex. And this will give us the highest, right? How should I do this so that it actually fits in? I'm going to make an arrow going that way. Gives the maximum height after X seconds. That's what the vertex will give you. And then this is, what would this point right here, we used to call this the x-intercept, and we still call it that, but within this context, what would you say that tells us? The time it stopped, right? The ball hits the ground? Yes. Time the object remained airborne. The time spent in the air, okay? It hits the ground there. And this will always be a number followed by 0. Okay, so we've found those before, so there's nothing new about that. One thing that is new, make sure you pay attention to this. Once we do word problems, you need to be careful because you're going to lose marks. We no longer, I know your calculator is going to show all of this, right? It's going to continue. But we are just interested in this. So please don't find, sometimes I ask students, like, how long was this object in the air? And they'll start counting from back here all the way to here, and that's not accurate, right? It's time starts here in our scenario, okay? Let's talk about domain and range. Your favorite topic. Not, okay? X values. Range would be my Y values. So in general, if we want set notation, it will be 0. So X will be between 0, especially when it's time, and the greatest X value. Honestly, I would not necessarily say you have to include this in your study sheet, because if you just looked at mine, I cover domain and range there. This is just revising it. Interval notation, right? D would be from 0 all the way to the greatest X value. For Y, for the range, we just go lowest Y, less than or equal to Y, less than or equal to greatest. And your range in interval notation will be lowest Y, comma, greatest. Okay. So let's practice with a few next on the next page there. So state the domain and range for all of these scenarios, and notice that every single one of these is going to have labels on the X and Y axis, and they're not just X and Y. So what we're going to do is we're going to assume that if this is length, that the variable is L, and A is up here. So we're going to assume that the variable is A. That, like, the equation that we would have for that would be A and L. Okay, so let's do the domain and the range for both of these. What are we assuming? I tried to make a dot right there what are the coordinates for this one? 0, 0. Yeah, don't underestimate the power of 0, 0. Okay, like origin is very important. Then you have your vertex, and then you have your where it ends. So we're comparing the length of a rectangle, let's say, to the resulting area. So for my domain, I already tell myself that this is domain. Let's do set notation first. We're looking at the x values here. So we're going to go from 0, that's the lowest, and we're trapped, right? We're trapped between two numbers. So we're going to use L, and we're going to say that that's less than or equal to 450. Okay? 0 to 450, so that's the set notation. If you wanted to use this one, which is my preferred method, you go from 0 inclusive to 450 inclusive. Okay? What about the range? The range we're looking at, let me help you out here. Maybe you need this because it's early morning. I use green, I think, for domain. I'll use green. So for domain, we're interested in these values, right? For range, we're interested in the y values. So I'm actually I'm going along the y, and you gotta kind of protract it over to the vertex. So if you will, we're going from 0 all the way to 450 for my x. And we're going from 0 all the way to, what is the y value there? It's big, it's 50,000, but it doesn't matter. Okay. So you know what the annoying part is about set notation? If you want to get full marks, you have to use the letter, the variable that the question is using. So if the equation uses L or T or M, whatever it is, that's the one you need to use here. So keep that in mind. So for range, we're going to go between 0, and this is A, less than or equal to. We're trapped as well. So when you're trapped, you have to have those inequality symbols on both ends. And they always face the same way, so you don't have to kind of worry about like when is it different. It always faces that way. And so we go from 0 to 50,000. There we go. You have your domain and range. So what I'm going to do is this page and 34, I'm going to ask you to do that whenever I'm done here. So it might be homework. If you have some time to do it here, you'll do it here. But I want you to practice this on your own a little bit before I do it, because I think I've done a lot of domain and range. So I'll say homework, page 33 to 34. Okay. That's your domain and range practice, because I want to get to the word problem. Okay. More problems. Okay. Can I just? I'm just going to leave it at that. Let's go to page 35. I'm going to post the key to the homework, so make sure you try it. Okay. Okay, so I want you to know effects of A, B, C to the curve. just briefly again. That one you already know. And I'm going to draw your attention to this one here. This is a constant. Shifts up, down. Okay? So what I would like you to have there is just one of these. And if you increase it, right, something happens. If you decrease it, something else happens. So what I'm going to do is I'm going to have C in the middle. If you increase it, you would shift the whole thing up. If you decrease it, right, if you take anything away from it, you would shift downwards. And you know what? I feel like more information is always better. Side shift. So what happens is you kind of shifts over to the side a little bit. So this is actually, if B is negative, the more negative you make it, the more it's going to shift that way. The more positive you make it, the more it's going to shift to the left. I don't know, I made them all pointing up, but you do understand that it could be pointing down and the same effects would be visible. Okay? You good? Fun stuff, eh? Yeah. This one you can't tell your parents about. You're going to impress them. Scenarios. For word problems. I will tell you the classic ones. I'm not saying there aren't more, but you may have a scenario where you start, a ball is kicked from the ground or something is starting from the ground, it goes up and then it hits the ground. Boom. Okay? You might have a scenario where you're higher up the ground, right, off the ground, and then you throw something up and it hits the ground. That's another scenario. Then you have another scenario where you're off the ground, okay, and instead of going up from there, then down, you're just going to go straight. It's almost like if you're running off of a cliff into the lake, right? If you don't jump, you would just do that, okay? So it doesn't go up first, then down. Then you might have, these are a bit more oddball questions, but let's say you're up here and you're diving into the water, and this represents the surface of the water. So in this case, we are going to go underneath the water. So you will jump in, you'll dive, you'll reach the lowest point, and then you'll surface right here. So that is also something that you could expect. And here I'm thinking of an eagle right here. Let's say an eagle is sitting on top of a branch or a tree. An eagle, comes down, maybe lands or just touches or just above, grabs its prey and then goes back up to the tree that Maybe it's the same tree, so it would be the same height again. So you end up at the same height of when you started. So these are scenarios that are very, very common. So something that you could expect. Okay, so having that in mind, I think helps us. By the way, this one here is unique. B is equal to 0. When B is equal to 0, then it's just straight down. It doesn't go up first then down. That's what you're going to encounter. So B is essentially not there. The equation will not have an x value, okay? But you know B is equal to 0. Okay, let's dive into our first word problem of this course. I'm going to start you off with scenarios where the equation is provided. So the path of the baseball that has been hit can be modeled by the following equation. Okay, so here is your equation. I'll say this. If you are given the equation, you put it into y1, no questions asked. Like, you're going to have to do that. So even if it's ugly and you're like, oh man, I've never seen this before, type it into y1 and let the calculator take care of the rest. Where h of t is the height in feet and t is the time in seconds. So right away, t is my x value. Why? Because it's to the right of the equation. This is my y value. So every single point is going to be time and height. Which way is this parabola opening? Up or down? It's down, right? We already know that. Okay? We already know that. So let's type that in and see what happens. I want you to find a good window. That's the main idea here. Because if you can't see it, it's not good. Okay? So negative 4.9 x squared plus 35x plus 4. Let's hit graph. I was just helping a grade 12 student earlier, so my window's probably not going to be the greatest. What should I do, guys? It's not good. Should I do a zoom 6? Maybe. I'll do a zoom 6. And I see both legs. Like, I saw it going up, and I'm seeing it going down. It's what I expected. I'm going to chase the curve, so I'm going to chase the top here. So I'm going to have to change my y values, and specifically y max. So I'm going to go, I'm going to try 40. 40 is not good enough for y max, so I'm going to press the window again. I'm getting impatient, so now I'm going to go double that. I'm going to go 80. I don't think you need to hit enter, but I usually do. 80 is a pretty good outcome for me. 80 is pretty good. And I'll tell you one more thing that I like to do is I don't like to see too much into the negatives if I don't need it. So what I'm going to do here, I'm going to go to my window, and almost by default, I change the x-min to -1 or -5, just a little bit to the left of the y-axis. So let's try -1. I think that will do it for us. See, so now you only see 1 unit to the left. So that's what this would be for me, a very workable window. Okay? Keep in mind that if you had a small curve, that'd be fine. You would still be fine. But I like to kind of visualize it, and I know that I'm sticking to this path because it's a baseball. It's going to hit the ground. We're not going underground, so we're good. Okay. If you can't see it, let's talk about it later. But for now, I need to continue. Okay. So, keeping this calculator right there. Okay. Let's answer some questions here. What is the initial height of the trajectory of the ball? In other words, i.e. means in other words, at what height was the ball hit? At time equals to 0 second is what we're interested in. This is the y-intercept. If time is equal to 0, we are essentially saying, hey, when x is equal to 0, what is y? Question, do I need my calculator for that? For the y-intercept? I don't, right? Because this is in general form. So it is 4. So if you know that it's 4, go for it. If you don't, you got to second trace value x is equal to 0, y is equal to 4. There it is, right? So it's whatever works for you. Just make sure you go second trace value x is equal to 0, okay? If you're going to use your calculator, tell me that you've done that. But you're not done yet. You have to be specific. So what is the height at the very beginning? 4. 4 what? What's height measured in this case? Feet. You need to explicitly tell us that it's 4 feet. If you just say 0.4, I understand you know what you're doing, but the province wants you to be very, very specific. So have units. Do I need a statement? No. I know some teachers would very much disagree. They want like a full-on sentence. You don't need that. Okay? So if you say 4 feet, you circle it, and you show us the work, you're good. Continue. B. Determine the maximum height of the ball. What are you thinking of in terms of intercepts and vertex? Which one am I going to look for if it's the maximum height? Vertex. Find vertex. How am I going to do that? I will go second, trace. The question kind of gives it away that it is maximum. So let's go ahead and find it. If you can't see it, you won't find it. So you need to see it on their graph. So second trace, maximum. Remember, this is your vertex. It wants something to the left of it. Hit enter. I am already left, so enter. Go past it. Make sure you go way past it. That's good enough. Once you started seeing going back down, you're good. Enter. Enter one more time. And there it is. I'm going to write down the coordinates, 3.57, 66.5. Does it hurt to go 50, Mr. Erickson? It does not hurt at all. So if you want to do that, you go for it. And I hate to tell you that this is still not good enough. What is the maximum height? 66.5 or 50 feet. That is the answer. What does the 3.57 represent? The time it takes to get to that highest point, right? So if the question asks you how long does it take to get to the maximum height, we would want you to state 3.57 and circle it. So this isn't good enough. It's very close, but you need to make sure you state the final answer. C. How long does it take for the ball to hit the ground? In other words, how long does the ball remain airborne? Find x-intercept. How do we do that again? Y2 is equal to 0. Second, trace, intersect. Now, this is what I want you to understand. I'm going to do a little sketch right here. This is just a sketch, so we don't care about scale or anything like that. I'm starting somewhere here. The ball is going up, and then you hit the ground. This is T, this is H. It's just a sketch to help you visualize the scenario. This is 0.4. This is 3.57, 66.5. This is great for stating the domain and range, guys, for you to do one of these on the side. Because I don't ask you for a graph, right? And so, do we care about this part right here? Do we care about this one? No, because that's negative time. We want this one in particular, because some students find that one. It's like, no, you're going back in time, right? You want to find this one. So let's go ahead and do that. We let y2 equal to 0. You hit graph. There it is. It's red now. So I'm going to go second trace 5. I'm going to go find the one to the right. I don't care about the one to the left. Enter, enter, enter. It's 7.26. Rounded. And just a recall. If y said something like 3.57 times e to the negative 10 or whatever, don't be writing 3.57. It is 0. We want it to be on the x-axis, okay? So let's just write this one down. 7.26, 0. So it takes 7.26 seconds. So you have to use units. And I'm going to label this 7.26, 0. So there you have it. So far, you've been doing finding intercepts, finding vertex, answering. D. Let me see if I can make D appear here. Watch this. This is new. Calculate the height of the ball 1.5 seconds after being hit. Would this make sense if I said this? If time is 1.5, what is y? Would that make sense to you? That is basically what's happening. I'm giving you the x value. They want to know the y value. They want to know the height. So I'm going to do that one more time here. 1.5 question mark. What function on our calculator would we use in this case? Second, it's going to be second trace. Yeah. Value. That's correct. Why value? Because remember how it blinks and says x, hey, give me an x value? So what is x value right now? It's 1.5. So we just type in 1.5. And we will figure out the y value. Remember, if you cannot see it, it cannot find it. So you have to be able to see it. So second trace, value 1.5. I'm going to hit enter and see it's right there. And it kind of makes sense. If you think about the scale that I have, this is 1.5. So it does make sense. So it's 45.48 and the height is measured in feet. This is good enough. If you circle it, if you have the number and units, you're good. Are we okay with this so far? Not yet? Okay, it'll happen. It'll happen. E. Determine the time the ball remains at or above 49. I'm going to actually go to the question. I need you to understand that one. This one is tricky, so I'm going to highlight this with a color. I want this to stand out. And I might actually take you to the study sheet that I've created and add this part. Maybe not today, but we'll do it in the days to come. So I'll put a little star here. This one is different. Determine the time the ball remains at or above 49 feet. Let's go look at it in E. I'm going to make my go down with the camera here. And I'm going to ask you to sketch this one more time. We're starting at 4. We go up. We hit the ground. Where is 49? Where's the, because this is 4, and then it goes all the way up to, what's our highest? 66? So 49, would you agree 49 is somewhere in here? Somewhere, just approximately? So let's go and figure out where it is exactly. So I'm giving you the height, right, of 49. So let's go to y equals, and what are we going to type into y2 in this case? We're going to type in 49. And watch what happens. If you hit graph, that is your 49 line exactly, okay? So what this question is asking, the ball is hit, right? It hit, you go up, you go up, you go up, you get to 49, and then there's a time that goes by where you are above it, at or above, right? Until you hit 49 again on your way down. So we want to know the time frame from here to here. So guess how many times, how many points we're going to have to find? We're going to have to find this point, and we're going to have to find this point. Okay? So grab your, if you have a color, graph the 49 line. This is y is equal to 49. And we're going to figure out this value right here. And we're going to find out this value right here. Because remember, this is time. Okay? And what do we use to find a point when two lines meet? Second, trace, intersect. So let's find the first one. I want you to go to the left. Or like go wherever you need to go to get closer to that intersection. That's close enough. Anywhere in there. If you want to be right on it, if that makes you feel better, you do it. Okay? Now we hit enter 3 times. Enter. Enter. And when it says guess, enter one more time. So this is the time it takes to get to 49 for the first time. I'm going to ask you to write down 4 decimals, not just 2, 4 decimals. So 1.6816. And then it flies above it until it hits it again. Let's find that time, shall we? Second, trace, intersect. Let's go all the way over to it. Once you're close, enter, enter, enter. 5.4613. 4 decimals. 5.4613. A lot of work, isn't it? Yeah, it is more work. This is going to be a 2-mark question if you have to do this ever. If you realize that that's what's happening. So let me ask you, how would we find out how much time was spent between here and here? How would we figure that out using these 2 numbers? If you want to know the time between, you're going to subtract these, right? If you subtract this from all of this, right? Because it takes 5 and something seconds to get to here. It took us 1.68 to get to here. So we need to take this chunk away from the total time so that we're left with this, okay? So what we're going to do is, we're going to say y2 is equal to 49. We're going to go second, trace, intersect. What happened there? Intersect. And we're going to, this is how I show my work. I just put these numbers down there. We're going to do delta t. What delta t is asking is to subtract the 2 times. So that's the difference. So this is t1, this is t2. We have 2 times there. We're going to go t2 minus t1. That's 5.4613 minus 1.6816. If you don't like the delta, that's fine. So then you type this in and subtract 5.4613. I'm doing this on my calculator on the side. It takes us 3.7797 seconds. I'm going to show you that on the calculator real quick here. So we round to 2 decimals now because we're ready to state our final answer. This is how this question would be marked. You get half a mark to find the first one, half a mark to find the second one, and you get a full mark for subtracting because it's a concept, right? So just so you know, that's how this one would be marked. And F is graphing. So F, we're going to do that on the back side of this, okay? Graph. So go to 37. I have a grid there for you. I remind you that each graph must have a good scale, points, and label. So let's do this. This is height in feet. This represents time in seconds. And I will do this on the side here. The vertex is 3.57, 66.5. The x-intercept is 7.260. The y-intercept is 0.4, so just like before. But Mr. Erickson, remember, we always graphed both x-intercepts. Do you remember that? Yes, I do, but it's a word problem now. The other x-intercept is like going into the negative, so we don't care about that one. So this is all we need. So in terms of the y values, the highest I get to is 66.5. Okay. So let's see here. If I go 10, 20, 30, 40, 50, 60, that's going to cut it a bit short. So let's see here if I can go 20, 40, 60. Maybe that's better. 20, 40, 60. Why didn't you go up by 15, Mr. Erickson? What was wrong with that? Nothing is wrong with going up by 15s. I just like to go up by something that's divisible by 10, if I can. It's easier for me to work. And now along the x-axis, the greatest x value you have to worry about is 7.26 in this scenario. So I'm going to try 2, 4, 6, 8, 10. That works pretty good. If I went by 1, I don't think I would have had enough space. It would have been at 6 here, right? So that's not good enough. Okay, 0, 4. This is 10. This is 5, so 0, 4 is right here. That's where I start. Bottom there. 3.57, 66.5. This is 3. 3.5 is right about there. So I'm going to go up that line and find a 66. This is 70. This is 65, so 66.5 is right about there. And last but not least, you plot the 7.225. So this is 7, because between 6 and 8. This is 7.5. I want 7.25 or so. I plot it right there. Okay. And now you connect the dots. I always go to my vertex for this one. Go vertex, open sideways, and then right to the y-intercept. Stop there. Do not go past it. This is a word problem. Then you go back to the vertex, and you connect to that x-intercept. If you want full marks, h of t, negative 4.9 t squared, plus 35t plus 4. And your favorite, okay, before we're done here, domain and range. Let's do interval notation. What's the lowest x value I'm allowed to have here? It starts at time 0, right? And the highest is 7.26. So this would go from 0 to 7.26. My range? What's the lowest y value I ever get to? Did you say something? Linus, did you say something or no? Did you hear that? He says 0. The lowest value I ever get to in terms of the y is 0. But Mr. Dirks, I'm at 4 here. Isn't that the lowest value? No. Go for the whole ride. At some point, we do get to 0. Okay, so the lowest value here is 0. Okay, it's not the 4. So you got to go for the whole ride to figure out what is my lowest y value I ever get to. So it is 0. And the highest I ever get to is 66.5. Okay, you know what? Let's not do set notation for this one. This is good. Because if I ask you for it, I'm okay with that. Okay. Do you want the set notation? You don't like set notation? Yeah. We can look at it, but we won't like talk to that person, right? We won't talk to you set notation, but we'll look at you every once in a while. We say hi. Okay. Anyways, I would like you to try 2 questions, which is going to be 38 and 39. You know what? I'll sweeten the deal here. You just need to promise me you're going to take the deal. Page 38, that's a word problem, plus, what was it? Page 33 to 34, domain and range. That's the one I want you to practice, right? This is domain and range. So I don't think I'm asking too much. And we'll do more word problems tomorrow.